Hi everybody, welcome to SMR Telugu Education. Next topic is arrays. Arrays. In arrays concept, you have to discuss an operator is called array index operator. Array index operator or array subscript operator. So what is an array? Array is a homogeneous elements, similar type of elements. We want to calculate the sum of 100 elements. We have to declare 100 variables, int a, int b, int c, and so on, 100 variables. It is very difficult to declare a variables. So simply have to define by using arrays is homogeneous elements, same type of elements. This is called derived data type. Derived data type. Array is a derived data type. So how to declare an array? Here you have to mention the type, which type of elements, name of the array, and you have to mention the size, and then semicolon. This is any type of data type. This is variable name, any name. This is size. So data type, variable name, you have to give any name, should be constant. Size should be constant value. Integer constant. Okay. Here we are declaring int array name is ARR, and then you have to mention the size. Here I am declaring 10. So for this, the memory is allocated for 10 elements. So I am declaring int ARR of 10. So this is the variable name is ARR. If you want, you can give any name. This is integer type of how many elements? 10 elements. The continuous memory is allocated for 10 elements. 10 elements. So this is the first, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here the name of the array is ARR. So please remember, in arrays the index is always starts from 0. This one is index starts from 0. The name of the array is ARR. Here the name of the variable is ARR. ARR. So every variable has some address. Similarly, array has a addresses. First address is, if you want, you can take any address. I want to take base address is 500. 500. Next address is integer size is 2 bytes. Next address is 502. Next address is 504, 506, 508, 510, 512, 514, 516, 518. The continuous memory is allocated. Here the initial values is garbage value. Any value, some garbage value. So garbage value. So every element has some name. First element name is error of 0, error of 0, so error of 0, error of 1, error of 2, error of 3, error of 4, error of 5, error of 6, error of 7, error of 8, error of 9. So this one is elements. Error of 0 means it gives garbage value. Error of 1 is which type of, this is integer type of element, this is integer type of element. These are the integer pointers. Okay, so first address is 500. It is address of error of 0. Next one is address of error of 1, address of error of 2. Next element is address of error of 3. Next address is address of error of 4. Next address of error of 5, address of error of 6, address of error of 7, address of error of 8, then address of error of 9. So please remember, in arrays, array name and base address both are pointing to the same location. That is the first element of an array. So in array, every array is a pointer constant. So this is a one pointer constant. Array name always gives base address of an array. This base address, this is the array. This array base address is 500. So address of error of 0 and error of both are same. Okay, next, this is the garbage values. If you want to any value in between, it's some integer values, minus 327682, so 32767, any value in between this, that is the garbage value. Okay, so please remember, this is the integer constant. The least size of an array is minimum one element. By mistake, if you give 0, then we will get an error. So int error of 0, then we will get an error. So the least size of an array is 1. So int error of, here I am giving int error of some size 10 is equal to, this is initialize an array by using curly braces, open curly brace, close curly brace. I am giving 10, 20, 30, 40 and 50, closed. Here the size of an array is 10. So index starts from 0 to 9, error of 0 to error of 9. So here in this case initial values is garbage values. Here the first element is 10, next element is, here the array is allocated of size 0 to 9, error of 0, error of 1, 0 to 9. Zero to 9. Here the first element is 10, next element is 20, next element is 30, so next element is 40, next element is 50, so remaining elements are 0. So 0, 0, 0, 0, then 0. So please remember, whenever we are initializing an array, the remaining values are zeros. Int size, here I am giving size is equal to 10, int error of, size is an integer type of variable, declaring size, semicolon. Okay, so run this code, we will get an error. So we will get an error. So please remember, here the array is integer constant, integer constants, variables are not allowed. By mistake if you give a variable, you will get an error. Int error of some size 3, array size is 3. Here I am initializing 10, 20, 30, 40, 50. So run this code, we will get an error. Here we are giving array size is 3, but here we are initializing too many initializations, 40, 50 are not allowed. We will run this code, we will get an error. Next, int error of some 10.5. So run this code, we will get an error. Here the size is integer constant. Here we are giving double value. That's why we will get an error. Next, int error of array size 2 is equal to, here I am giving 10 and 20. So this is valid. Our array size is 2. First element is error of 0, error of 0, next element is error of 1. Just taking some addresses 500 and then 600. Sorry, integer size is 2 bytes, next value is 502. Here the first value is 10, next value is 20. Next we have to print these two values. Printf %d error of 0, it will give 10. Printf %d error of 1, it gives 20. Here I am giving error of 2 is equal to 30, error of 3 is equal to 40. Here I am printf percentage d, percentage d, percentage d, percentage d, comma error of 0, comma error of 1, comma error of 2, comma error of 3. So run this code, we will get 10, 20, 30, 40 is the output. Here we are giving array size is 2, but we are initializing 4 elements. There is no boundary checking for an array in C language. Note. So there is no boundary checking for an array in C language. This is valid. We have to run this code. Here I am taking file name is array.c. So void main. Here I am declaring array size is int arr of 10. This is continuous memory is allocated for 10 elements. Here I want to debug this code. Watches, remove all watches. So watches, add. Here I am adding array name. What is the name of the array? ARR. So the memory is allocated for 10 continuous elements. Memory is allocated for continuous elements. So F7. So I want to print that values. F7, so small for S. Watch. Undefined symbol ARR. Our execution starts from main method. Void main. Int ARR of 10. So I am printing printf. So memory is allocated for 9 elements. Every element has some address. Here I am giving percentage u, percentage u, percentage u, percentage u for printing addresses. Percentage u, percentage u, percentage u, percentage u, percentage u, comma address is first element is address of ARR of 0. Next one is address of ARR of 1. Address of ARR of 2. Address of ARR of 3. Address of ARR of 4. Address of ARR of 5. Address of ARR of 6. Address of ARR of 7. Address of ARR of 8. Address of ARR of 9. And I have to print that values. So printf, copy this code, control insert for copy, paste this code, shift insert is the paste. Percentage d, 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 percentage d. Here remove the address operator. First element is ARR of 0, ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5, ARR of error of 6, error of 7, error of 8, then error of 9. Okay, so run this code. Execution is always starts from main method. Add watch. Here name of the array is error. So watches, add watch. I am adding array name error F7. Here execution is not start, that's why undefined symbol error. Whenever the control goes to the main function, memory is allocated for 10 elements. So first element error of 0, error of 1, error of 2, error of 3, 4, 5, 6, 7, 8, 9. 0 to 9. Initial values is garbage value. This is the first address. Address of error of 0, address of error of 1, error of 2, 3, and these are the addresses. So F7, Alt F5. So first address is 65,506. Second address is 508, 510, 512, 514, 516. That continuous memory is allocated. So instead of here, I am writing /n /n. These are the values. So these are the addresses. So F2, F7 is Windows watch, undefined symbol, memory is allocated for 10 elements. Alt F5. So these are the addresses, these are the values. So better to write CLR SCR to clear the screen. CLR SCR, clear the screen. So these are the addresses, these are the values. Alt F9 is Control F9. So Alt F5. These are the addresses, these are the garbage values. So please remember, here the array size is integer constant. By mistake, if you give, here I am giving array size is 0, then we will get an error. Comment this code. Alt F9, one error. So array must have at least one element. The least size of an array is one element. Here I am giving array size is 10. Here I am initializing 10, 20, 30, 40, 50. Then remaining elements are zeros, not a garbage values. So run this code, Alt F5, debug this code, F7, Windows, watch, array sizes, initial garbage values. Whenever this statement is executed, first element is 10, 20, 30, 40, 50. Remaining all are 0, 0, 0, 0. So 10, 20, 30, 40, 50. Remaining elements are 0, 0, 0. These are the addresses, these are the values. Alt F5. Okay. So I want to clear this screen every time. CLR SCR. Next. Here I am giving array size is 2, but here I am initializing too many values, 40, 50. Then we will get an error. Alt F9. Here the array size is 1, 2, not 12. Alt F9, one error. Enter. Too many initializers. Here array size is 2, then you have to initialize only 2 values. But if you want, we can initialize the assign the values. Error of 3 is equal to 30, error of 2 is equal to 30, error of 3 is equal to 40, and so on. But now values, this code is running control F9 alt F5 10 20 30 40 remaining are 0 0 0. Okay, this is the array how to initialize. Next, one more thing, here the size, this should be integer constant. By mistake, so comment this code. By mistake here I am giving 20.5, some double value I am giving. Run this code, will get an error. Constant expression required. Okay. So every name, every array has some type. Which type? Same type of values. If you want, you can assign some integers, some constants are not allowed in arrays. Okay. So this is just a declaration. How to declare an array? How to? Every array has some addresses and some values. Array index is starts from 0 to, if size is n, last element is n minus 1. Okay. So thank you for watching. So what is the output of a given program? So what is the output of void main int error of some size 10, elements are 8, 18, 28, 38 and then 48. Int asterisk ptr. So ptr is equal to address of error of 0 plus plus ptr plus plus ptr plus plus asterisk ptr, then printf percentage d comma asterisk ptr. So what is the output of this program? Okay, so our execution is always starts from main method. Here the array size is 5, array name is arr. The memory is allocated for 5 elements. So 5 elements. First element is arr of 0, arr of 1, arr of 2, arr of 3 and arr of 4. Error of 1, error of 2, error of 3, error of 4. Here in some addresses, here I am taking the initial address is 500, next address is 502, next address is 504, 504. Next address is 506, next address is 508. Continuous memory is allocated. Here the name of the array is arr. So name of the array is arr. Array name always gives pointing to first address. So these are the initial values 5, 8. First value is 8, next value is 18, next value is 28, next value is 38, next value is 48. Next, int asterisk ptr. Here memory is allocated for ptr. Ptr is a pointer variable. So memory is allocated for so variable name is ptr, some address I will take 600. So initial value is garbage value. Okay, next this statement is executed. Ptr is equal to address of error of 0. Error of 0 is 8. Address of error of 0 is 500. So this value is this garbage value is replaced with address of error of 0, that is 500. So this value is 500. Next, our ptr is pointing to this address. Okay, so next plus plus ptr, whenever you are incrementing the ptr, it is pointing to next location. This is first variable, first location is 500, next location is 502. Whenever we are incrementing the pointer, it is pointing to the next address. So plus plus ptr means this one is replaced with 502. Now the ptr is pointing to this address. Next, this statement is executed, plus plus ptr, that means ptr is pointing to next location. This is next location is 504. This memory is, this value is replaced with 504. Now the pointer is pointing to this location. Next, this statement is executed, plus plus asterisk ptr. First asterisk ptr is executed, asterisk ptr. So what is ptr? Ptr is 504. Asterisk ptr means 504 address variable, that is ARR of 2. So here ARR of 2 plus plus, that means ARR of 2 plus plus means this value is incremented by 1. So this value is 29. Next, this statement is executed, printf percentage is d asterisk ptr. What is ptr? 504. What is asterisk ptr? Asterisk ptr means ptr is 504. Asterisk ptr means 504 address variable, that is ARR of 2. Indirectly ARR of 2 value is 29. So 29 is printed output. Okay. So we want to execute this code. So file name is array1.c f5 void main. Here I am declaring array of size 5. So assign the values 8, 18, 28, 38, 48. So int asterisk ptr. So clear the screen, clr scr. ptr is equal to address of ARR of 0. So plus plus ptr means ptr is pointing to next address, plus plus ptr plus plus asterisk ptr, and then printf percentage d comma address of asterisk ptr. So debug this code. Want to add watches of array name is ARR. So F7. So memory is allocated 5 elements. First element is 10, 20, 30, 40, 50. Here ptr. So want to add ptr. So ptr default value is some garbage value. Now the address of ARR of 0 is stored in ptr ffec plus plus ptr. Ptr value changed to next address. This value is changed to ffee. Next plus plus ptr. Next ptr is pointing to this address. This value is changed. Next asterisk ptr. Asterisk ptr means this address variable, that is ARR of 2 is increment by one value. This value is changed to 29. This value is changed to 29. So PTR is this address, asterisk PTR is this address variable, that is ARR of 2, value is 29. So F5, so output is 29. So please remember, the base address of an array and the first element address of ARR of 0 both are same. So instead of I am writing address of ARR of 0, direct I am writing ARR, both are same. So Alt F9, yes, F7. So A PTR, this value is changed to 29 and then 29. Alt F5. Okay, so this is the array with pointers. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next topic is, what is the output of a given program? Void main int ARR of size 10. I will take size is 5. Take their elements 10, 14, 24, 34, then 44. So plus ARR plus asterisk ARR plus asterisk ARR printf %d comma asterisk ARR. So what is the output of this program? Okay, so you have to run this code. Here array size is 5, the memory is allocated for 5 elements. So first element, second element, third, fourth and fifth. Here the name of the array is ARR. So first array element is ARR of 0, ARR of 1, next element ARR of 2, next element ARR of 3, next element ARR of 4. So every array has first element is 4, next one 14, 24, 34, then 44. Here the starting address is, I will take 500, next address is 502, next address is 504, next address is 506, next address is 508. Here the name of the array is ARR. So array name always pointing the address of the first element. So next this statement is executed. So we have to run this code. What is ARR? ARR is the address of base array. This array base address is 500. Here ARR is 500. Whenever we are applying plus operator on constants, then we will get an error. We have to run this code. We will get an error. So please remember, array name always gives base address of an array. So array name is a pointer constant. So array name is a pointer constant. So that's why we will have to, that's why here we have to get the error. To execute this code, Alt F new F2. I will take file name is point array3 C, F5, void main. Here we are declaring int array of size is 5, elements are 4, 14, 24, 24, 34, 44. Here plus plus arr plus plus asterisk arr plus plus asterisk arr, then printf percentage d comma asterisk arr. So alt F5, run this code, will get an error. So this is the error. This is the arr is the array name. Array name always gives pointer base address of an array. It is a pointer constant. That way you will get an error. Okay. So here commenting this line, then so I want to comment this line. Comment this line. What is ARR? ARR is 500. So what is asterisk ARR? Asterisk means 500 address variable, that is ARR of 0. ARR of 0 increment by 1. That means this value is replaced with 5. Next, once again asterisk ARR. ARR means 500. Asterisk means error of 0 is increment by 1. That means 5 value is increment by 1. This value is 6. So here asterisk printf percentage d asterisk arr. What is arr? 500. Asterisk arr 500 address variable, that is arr of 0. That value is equal to 6. Here I am writing CLRS here to clear the screen. So alt F5, yes, control F5. So output is alt F5. Output is 6. So how to debug this code? F7. So array name is ARR Windows Watch. So F7, memory is allocated for 5 elements. First element is 4, 14, 24, 34, 44. Asterisk ARR. First element, this value is increment by 1. Whenever complete this execution of this statement, this value is 5. Once again, ARR means first address of, asterisk means this ARR of 0 increment by 1. This value is 6. Once again, ARR is base address of array. Asterisk means this value 6 is printed. Alt F5, 6 is the output. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So void main int arr of, will take some size a is equal to, array size is 5, first element 9, 19, 29, 39, 49. So int asterisk ptr. So ptr is equal to, just here I am printing printf percentage d space percentage d space percentage d space percentage d comma arr of 2 comma 2 of arr comma asterisk of arr plus 2 comma asterisk of 2 plus arr. So what is the output of this program? Okay. So here arr of 5 is, memory is allocated for 5 elements. So the array size is The memory is allocated for 5 elements. So first element is first, second, third, fourth, fifth. First array name is error of 0. So next one is error of 1. Next one is error of 2. Next one is error of 3. Next one is error of 4. So every array some base address. Here I am taking 500. Next address is 502. Next address 504. Next address 506. Next address 508. If the values is first starting value is 9. Next one is 19, 29, 39, 49. Here the base array name is pointing to first location. Here the name of an array is ARR. So here what is ARR? ARR is equal to array name always gives base address of an array. Here the base address of an array is 500. ARR is 500. So what is asterisk ARR? Asterisk ARR is 500 address variable, that is ARR of 0. ARR of 0, that value is equal to 9. So what is ARR plus 1? So whenever ARR is base address of an array, whenever we adding one value to the address, it is pointing to next address. That means ARR plus 1, the value is equal to the value is equal to 502. So what is asterisk ARR plus 1? So ARR plus 1 is 502. Asterisk means 502 address variable, that is ARR of 1. ARR of 1, this value is equal to 19. Next one is ARR of plus 2, value is equal to next address. ARR plus 2 is equal to 504. Asterisk means asterisk ARR plus 2. 504 address variable, that is ARR of 2. This value is equal to ARR of 2. So ARR of 2 value is equal to 29. So ARR of 2 value is equal to 29. Similarly, this is asterisk ARR of 2. ARR of 2 can be written as asterisk ARR of 2. This asterisk ARR plus 2 is also written in the form of asterisk ARR 2 plus ARR. Both are same. This value is equal to ARR of 2. This value is equal to 29. Similarly, manu ARR of 2 can be written as 2 of ARR. This is also can be written as asterisk 2 plus ARR. So this value is equal to ARR of 2, that value is equal to 29. So you have to run this code. ARR of 2 value is 29. 2 ARR of 2 of ARR value is equal to 29. Asterisk ARR plus 2 value is 29. Asterisk 2 plus ARR value is equal to 29. So now ARR of 4 can be written as asterisk ARR plus 4. So ARR of 4 can be written as asterisk ARR plus 4, or 4 of ARR can be written as asterisk 4 plus ARR of. All are same. You have to run this code. New file F2. So take file name is arr4.c. So void main. So int arr of 5 will take array size equal to 5. Values are 9, 19, 29, 39, 49. Here printf %d space %d space %d space %d comma arr of 2 comma 2 of arr comma asterisk arr plus 2 comma asterisk 2 plus arr. So all are same. Here clear the screen. CLR SCR F2 save. Alt F9 yes. Debug this code. Initial starting value is 9, 19, 29, 39, 49. Error of 2 values 29. Alt F5 29, 29, 29. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So void main. We are declaring array size is 5. Assign the values are 8, 18, 28, 38, 48. So int asterisk ptr. So ptr is equal to arr plus 1. So ptr plus plus or plus plus ptr, anything plus plus ptr plus plus asterisk ptr next plus plus ptr minus minus asterisk ptr, then printf %d %d comma ptr of -1 comma ptr of 0 comma ptr of 1. So what is the output of a given program? Okay, here the array size is 5. So memory is allocated for 5 elements. So first element, second element, third, and then fourth. The name of the array is arr. The first element is arr of 0, next element arr of 1, next one is arr of 2, arr of 3, arr of 4. With the base addresses, first address is I am taking 500, next address is 502, next address is 504, next address is 506, next address is 508. So first element is 8, next one is 18, next element 28, next element 38, next element is 48. So int asterisk ptr. Ptr is a pointer variable. The memory is allocated for ptr. Variable name is ptr. So I will take some base address 600. Initial value is garbage value. Next, PTR is equal to, this is the base address. Array name always gives base address of an array. So ARR. So ARR value is base address of an array. Base address of an array is 500. Okay, next, PTR is equal to ARR plus 1. ARR plus 1 means it is pointing to next address. Next address is 502. 502 is stored in PTR. So this value is replaced with 502. 502. Now PTR is pointing to this address. Next, plus PTR. That means the PTR is increment by 1. Okay, PTR value is 502. It is increment by 1. That means whenever we have to increment the pointer, it is pointing to next location. Okay, so this is integer pointer. Whenever you are increment the 1, it is increment by next address, that is 504. This can be replaced with 504. Now this one is pointing to this address. Next, so PTR means 504, asterisk PTR means 504 address variable, that is ARR of 2 is increment by 1 plus plus. That means this value is increment by 1. This value is 29. Next, plus PTR. Next PTR is pointing to next location. Here next address is 506. 506. Now the pointer is pointing to this location. Okay, next one. The statement is executed. What is PTR? PTR is 506. What is asterisk PTR? 506 address variable, that is ARR of 3 is decrement by 1 minus minus. That means this value is decrement by 1. This value should be replaced with 37. Next, PTR of minus 1, PTR of 0, PTR of 1. So PTR of 1 can be written as PTR of minus 1 can be written as asterisk PTR minus 1. So what is PTR? 506. Minus 1 means it is pointing to previous address. 504. Asterisk means asterisk of 504. Asterisk means 504 address variable, that is ARR of 2. So ARR of 2 value is 29. ARR of 2. This value is equal to 29. Next, PTR of 0. So PTR of 0 can be written as asterisk PTR plus 0. So PTR is 506. Asterisk means 506 address variable, that is ARR of 3. So ARR of 3 value is 39. 7. Next, PTR of 1, that this can be written as asterisk PTR plus 1. So asterisk PTR is 506, asterisk means plus 1 means it is pointing to next address. This value asterisk means 508 address variable, error of 4. Error of 4 value is 48. We have to run this code. The output is 29, 37 and 48. We have to run this code. Void main. Save this file F2. So file name is error of 5.c. So void main int error of 5. So values is 8, 18, 28, 38, 48. So int asterisk of PTR. PTR is equal to error plus 1. So plus PTR plus asterisk PTR plus PTR minus asterisk PTR. So printf %d space %d space %d comma PTR minus 1 comma PTR of 0 comma PTR of 1. So F7 array size. Here I am declare debug. I will also adding PTR value. So initial value is garbage value. Next address is error plus 1 means error of 1 address. F7 address. Now PTR is pointing to this value. Next PTR is incremented by 1. It is pointing to 28. This value is changed. Next asterisk PTR means error of 2. This value is incremented by 1. This is 29. This value is 29. Next PTR value is pointing to this address. Address is changed. Next asterisk PTR is error of 3. It is decrement by 1. This is 37. Next PTR. Now PTR is pointing to 37. PTR minus 1 means pointing to previous address. This is 29. PTR of 0 means 37. PTR of 1 means pointing to the next address 48. So Alt F5. So output is just to clear the screen. CLR SCR F2 Alt F9 yes, Control F9 Alt F5 Alt F5 29, 37, 48. Hi everybody, welcome to SMR Telugu Education. So next one is, what is the output of a given program? So in this program, what is the output of a given program? So in this, our execution is always starts from main function, and A, B, C are the single dimensional arrays. Memory is allocated for A, A size is 4 elements. First one, second one, third one. Here the name first element is A of 0, A of 0. Next one is A of 1, A of 2, A of 3. Next, first address is 500. Next address is 502, 504, 506. Next, one more array of size 3 element 4. Array name is B. First element, second element, third element. Here the first array values are, first value is 4, next one is 14, next one is 24, next one is 34. Here the array name is B. So first element is B of 0, B of 0, B of 1, B of 2, B of 3. So here addresses is, first address is 600, next address is 602, 603, 604, 606. 604, 606. Here the values are, first element is 6, next one is 16, next one is 26, next value is 36. Next array name is C. So C of 0, C of 1, C of 2, C of 3. So C of 0, C of 1, C of 2, C of 3. Here the base address is 700, next address is 702, next address is 704, next address is 706. The elements are, first element is 9, next one is 19, next one is 29, 39. Here the PTR3 is int star PTR. That means array of size 3 elements. PTR is a variable name is PTR. First element is PTR of 0, PTR of 1, PTR of 2. Pointer, array of integer pointer. PTR is a array variable of type integer pointer. So here the variable name is PTR. First element is PTR of 0, next element is PTR of 1, next element is PTR of 2. Here taking base address is 600, next address is 800, next address is 802, next address is 804. So initial values is garbage values. This one is garbage value, then garbage value. Next, int star star PPTR. Here the name of array is PPTR. Name of array is PTR. This array name is A. So array name always gives base address of an array. This array name is This array name is B. This array name is C. So array name always gives base address of an array. This array name is ptr. Ptr also always gives base address of an array. Next, int asterisk pptr. The variable name is pptr, some address 900. So initial value is garbage value. Next, int I. I is a one variable. Memory is allocated for I. The variable name is I. Some address I will take 950. So initial value is garbage value. Next, what is A? A is a base address of an array. Here the base address of array is 500. 500 is stored in ptr of 0. So ptr of 0, this garbage value is replaced with this value is replaced with 500. 500. Now ptr of 0 is pointing to this element. Next, ptr of 1 is equal to b. B value is 600. Base address of array 600 is stored in ptr of 1. Now this pointer is pointing to this address. Next, ptr2 is equal to c. C is gives base address of array which is 700. That 700 is stored in ptr of 2. Now this pointer is pointing to next. Pptr is equal to ptr. So what is ptr? Ptr is base address of this array. Base address of this array is 800. This 800 is stored in pptr. So this value is replaced with 800. Now pptr is pointing to this address. Next, I is equal to 1. This garbage value is replaced with 1. So value of I is 1. So 1 less than or equal to 3. Yes, condition true. This statement is executed. So what is pptr? Pptr value is 800. So what is asterisk pptr? Asterisk pptr is 800 address variable, that is ptr of 0. Ptr of 0 pptr is 800 asterisk pptr is 800 address variable ptr of 0, that is 500, is increment by I, that value is 1. So asterisk pptr is equal to asterisk pptr plus 1, that means this value is increment by 1. This should be replaced with 502. Now this one is pointing to 502. This one is reallocated. Next, asterisk pptr plus is equal to asterisk pptr plus I. So what is pptr? Here the pptr is 800, asterisk pptr is 800 address variable ptr of 0, that value is 502. Asterisk means 502 address variable. 502 address variable is a of 1 is increment by 1, that means ar of 1 is 14 plus 1. Now this value is 15. Next, plus pptr. So pptr value is increment by 1. So this value is equal to 802. Now this one is pointing to 802. So this pointer is deallocated. Next, I value is increment by 1. So I value is 2. So 2 less than or equal to 3. Yes, condition true. Asterisk pptr. Pptr is 802. Asterisk means 802 address variable. This one is increment by I value is 2. Increment by 2. That means this is integer pointer. Plus 1 means pointing to next address 602. Plus 1 means pointing to next address 604. Now this one is pointing to this address. This memory is deallocated. Now, so asterisk pptr plus equal to I. So asterisk pptr is 602 address variable, that is ptr of 1. Asterisk means this value is 604. Now this point is pointing to 604. So asterisk pptr means 604 address variable, that is b of 2 is increment by 2. This value is increment by 2, that value is 24. 8. Next, plus plus pptr. So pptr value is increment by 1. So this value is increment by 1. That is next to address 604. Now this one is pointing to 604 804. Now this memory is, this link is deallocated. Now pptr is 804, asterisk pptr is 804 address variable, that is ptr of 2 is increment by I value is 3. Here the I value changed to 3. So 3 less than or equal to 3 as condition true, asterisk pptr is increment by I, that is asterisk pptr plus 3. So pptr is 804, asterisk pptr is ptr 2 increment by 3. That means this value is 706. Now this one is pointing to this value. Asterisk pptr. pptr is 804, asterisk pptr is 706. Asterisk means 706 address variable. C3 is increment by 3. That means this value is increment by 3, that is 42. Next, plus plus pptr. Next, pptr is increment by 1. That means this value is 806. Next, I value is 4. 4 less than or equal to 3. Condition false, out of the loop. Next, minus minus pptr. pptr is 806, minus minus means 804. So pptr value is 804. Now this one is pointing to this address. Next, what is asterisk pptr? pptr is 804, asterisk means ptr of 2, asterisk means 706 variable C3 is 42. Here the 42 is printed 42. So next one is I is equal to 0. Once again I value is 0. 0 less than 3, condition true. Asterisk ptr of 0. ptr of 0 is 502. Asterisk means 502 address variable A1. That value is 15. Next, I value is 1. 1 less than 3, condition true. ptr of 1. Asterisk ptr of 1. ptr of 1 is 604. Asterisk means 604 address variable, that is B2. B2 value is 42. 28. Next, I value is 2. 2 less than 3. Yes, condition true. Asterisk ptr of 2. ptr of 2 is 706. asterisk means 706 address variable C3. So value is 42. 42 is printed. Next I value is 3. 3 less than 3 condition false, out of the loop. Next for I is equal to 0, I less than 4, I less than 4, 0 less than 4, condition true. A of 0, B of 0, C of 0. A of 0 is 4, A of 0 is 4, B of 0 is 6, C of 0 is 9. So here the output is 4 space 6 space 9. Next I value is 1, 1 less than 4, condition true. A of 1, B of 1, C of 1, 15, 16, 19. Next I value is 2, 2 less than 4, condition true. A of 2, B of 2, C of 2. Next I value is 3, so 3 less than 4, condition true. A of 3, B of 3, C of 3. That value is 42. Next I value is 4, 4 less than 4, condition false, out of the loop. Okay, this is the output. So we have to run this code. So alt F9, yes, control F9, alt F5. So A value is asterisk asterisk PPTR is 42, star asterisk PTR of 0, asterisk PTR of 1, asterisk PTR of 2, 15, 28, 42. A of 0, B of 0, C of 0, 4, 6, 9. B of 1, C of 1, A of 1, B of 1, C of 1. Next values are A of 2, B of 2, C of 2. Next one I will use A of 3, B of 3, C of 3. So F7. So how to debug this code? A, B, C. Next PTR of 3, PPTR. Next here I value, we are adding I. So starting value is A, B, C, memory is allocated, A, B, C, PTR, starting address. A address is stored in PTR of 0, this one is B value, B address is stored in PTR of 1, C address is stored in PTR of. Next PPTR is equal to PTR, this base address is stored in PPTR. I is equal to next I is equal to 0, PPTR plus I. So this value, this address, first this address is changed. PPTR is this one, asterisk PPTR is this address is incremented by 1. This value is changed. E changed to F0. Next asterisk means this address is this one. This value is incremented by 1. That one 14 value should be 15. This value should be 15. Next plus PPTR. This value is incremented by 1. Now this one is I value is 1, 2, 2 less than or equal to 3. Now this address is changed. EA. Now this address is 604, 601, 2, 3. This is the 604 address. Now this one is pointing to this address. Asterisk means B of 2 is incremented by 2. This value is 28. This value changed to 28. Next plus PPTR. Next this value is increment by 1. This one is pointing to this address DC. Next I value is 3. 3 less than or equal to 3 as condition true. Now this address is changed to 706. This value is changed. Now this one is pointing to this address. Asterisk means this address. Asterisk means C of 3 is increment by 3. This value is changed to 42. Now this value is 42. Plus plus PPTR. Now this value is changed. Once again we are decrementing. Once again this is pointing to previous address. Now this address is pointing to this one. Asterisk PTR is this one. Asterisk means this value 42. So this statement prints 42. Alt F5, output is 42. Now so I is equal to 0. PTR of this address is pointing to this one. Asterisk PTR of 0 is 15. Next this address is pointing to this one. Asterisk PTR of 1 is 28. Next this address is pointing to this one. Asterisk PTR of 2 is 42. First one F5, first value is 15. 15 is printed. Next value is Alt F5, 28 is printed. Next F7, Alt F5, 42 is printed. Next this one is A of 0, B of 0, C of 0. A of 0, B of 0, C of 0. 4, 6, 9 is printed. F5, 4, 6, 9. Second time 15, 16, 19. Alt F5. Next one 24, 28, 29. F7, Alt F5. Next one 34, 36, 42. Alt F5. Next F7 out of the body. Hi everybody, welcome to SMR Telugu Education. So next topic is write a program to find sum of sum and average of a given array. Okay. So first you have to declare one array of size. Here I am fixing the size. Array size is 10. You have to declare array size is 10. Year of 0, year of 1, year of 2, year of 3, 4, 5, 6, 7, 8, 9, 10. Okay. Array size is fixed. How to declare? Int error of array size is 10. Next, here the array elements are error of 0, error of 1 up to error of 9. Error of 9. Error of 9. So this is the address. First address is address of error of 0. Next one is address of error of 1, address of error of up to address of error of 9. Okay. First you have to scan the values. Here ask the end user to enter the values. So printf enter 10 array elements. 10 array elements and scan the values. Here I am writing for loop for I is equal to index starts from 0, so I less than 10, I plus plus. So scanf %d comma address of error of I. So whenever this statement is executed first time, this is the address of error of 0. First entered value is 10. This is stored in error of 0. Address of error of 0. It is second time, next address. Third time, next address. 4, next value. Fifth. This loop is repeated 10 times. 10 elements are stored in our array. For suppose here we are entering 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So array size 10 means 0 to n minus 1. Okay, now we are the entering the values. Now you have to calculate the sum of first element, AR of 0 plus AR of 1, AR of 2, AR of 3, and so on up to AR of 9. We have to calculate the sum. Initially you have to declare integer sum. Initial value is 0. You have to calculate the sum of each element. Once again you have to write the loop I is equal to 0, I less than 10, I plus plus. So for every time, first time sum is equal to sum plus ARR of I. Whenever this statement is this loop is executed, first time 10 is added to sum, second time 20, next time 30, and so on up to 100. Okay, the sum is calculated. Next you have to print sum. Print sum is equal to percentage d comma sum. Then you have to find out the average. Printf average is equal to, so initially here I am declaring some float value, float average is equal to, initial value is 0.0. Here the average is equal to sum by number of elements 10, and then print the average. Printf average is equal to percentage f comma average. Okay, so to run this code, write this code, alt f new f5 f2 sum dot c. So I am declaring array size is 10. So int error of 10. Next for sum you have to declare sum is equal to 0. For average and declaring float average. For loop purpose I am declaring f I or I. Okay. Next ask the user printf enter array elements. Next scan that values I is equal to 0, I less than 10, I plus plus. So scanf. If you want, you can ask the enter first element, second element, third element message. So printf enter percentage d element comma I. Here the starting value is I value is 0, that's why here I am writing I plus 1. Here enter first element first time, second time enter second element, and the scanf percentage d comma address of ARR of I. Okay, where scan the values. Next you have to calculate the sum. So once again for I is equal to 0, I less than 10, I plus plus. So sum is equal to sum plus ARR of I. After executing this code, sum is present in sum of array elements is percentage d comma sum. Next we have to calculate the average. So average is equal to sum by 10. So here better to convert, or I am taking 10.0. So here I am converting this to float. Here average default value, no need to initialize, default value 0.0. Next printf average of array elements is percentage f comma average. Here just use clear the screen, clr ser f2, save this one. So first you have to debug this code. So delete watch of ptr. Delete. Here you have to add average and sum. Add sum and average. So F7. So initial values is garbage values, sum initial value, garbage value, take sum is equal to 0. Float is also some garbage value 0.0. So enter array elements. Alt F5 it shows enter array elements. F7. So enter first array element and enter the first element 10. Once again F7. This loop is repeated total, so 10 times. Second time enter second element 20. Third time 30. Fourth time 40. Next time 50. F7. Next time 60. Next time 70. Next time 80. Next time 90. F7 100. So this loop is repeated 10 times. Next I value is 10, condition false, out of the loop. Now you have to, this loop is repeated so 10 times. First time sum value is initial 0, 0 plus 10. This sum value is 10. Look at here 10. Second time high value is 1, 1 less than 10, true. Year of 1 20, 10 plus 20 30. Next time 30 plus 30 60, 60 plus 40 100. Next 100 plus 50 150 plus 60 210. Next one plus 70 280. Next plus 80 360 plus 90 450. Next plus 100 550. The sum of array elements is 550. Alt F5. The sum of array elements is 550. Next 550 can be converted into float. Next divided by 10. 55.0. The average of array elements is Alt F5. Average of array elements is 55.6 decimal place. Hi everybody, welcome to SMR Telugu Education. So next topic is write a program to find minimum value and minimum index. Maximum value maximum index of given array. Write a program to find minimum value and minimum index, maximum value and maximum index of a given array. Here we have to take array size is 10. 10 elements. First element, second, third, fourth, fifth, sixth, 7, 8, 9, 10. Here I am taking the base addresses 500, 502, 502, 504, 506, 508, 510, 512, 514, 516, 518. The first element is ARR of, here I am declaring array name is ARR, the base address, take array name as ARR. So first element is ARR of 0, ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5, ARR of 6, ARR of 7, ARR of 8, ARR of 9. So 7, 8, 9. So initial values are some garbage values. Here I am entering some values. Entering values are 5, 9, some 4, some 10, then 8, take 28, take entering 3, 6, 21, and then 1. So in this program you have to find the, in this array you have to find the minimum value and minimum index. Here the minimum value is 9. In this example the minimum value is 9, the minimum value is 1, minimum index is 9. What is the maximum value? Maximum value is 28 and maximum index is 5. Okay, so how to calculate these values? Here I am taking the first array element, I am taken as minimum value and maximum value, minimum index and maximum index. Here you have to declare variables. So minimum value is equal to ARR of 0 and minimum index is equal to 0. Next, maximum value is equal to ARR of 0. Here I am taking maximum value is 5 and then maximum index is 0. Okay, so first I am taking the first element, ARR of 0 is minimum value, minimum index, maximum value and maximum index. Now I am comparing from these values. We are comparing from ARR of 1 to all these values. So in first iteration, here I am taking first value is ARR of 1, ARR of 1, okay. So now we have to compare the minimum value. Already we are comparing from array of 1 to 9. Here the initial value is, starting value is fixed. Starting value is, here I am taking I value is, starting value is 1. So I less than or equal to, up to last values we are comparing from 1 to 9 and I plus plus. I plus plus. This is the loop. Here what is the value of I? Here the value of I is this is I. So I value is 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, first you have to compare first element ARR of 1 with the minimum value and ARR of 1 with the maximum value. So here I am checking this particular condition is true. That means if let me check the condition, if we have to compare minimum value and ARR of I value. Here I is starting from 1. We have to compare these two values. Whenever the minimum value is greater than ARR of I. So this condition is true. That means the minimum value is, we have to change the minimum value. Minimum value is ARR of I. And then minimum index is I value. I value. So once again you have to check the condition if maximum value and ARR of I value. Once again you have to check if you have to compare maximum value and ARR of I value. We have to compare these two values. Whenever the maximum value is less than ARR of I, that means ARR of I value is maximum, then you have to assign maximum is equal to ARR of I, and then maximum index is equal to I. So first you have to check this condition with I is equal to 1. Okay, first I is equal to 1, yes, condition I is equal to 1, I less than or equal to 9, yes, condition true. We have to check ARR of I, ARR of 1 with the minimum value. Minimum value is, what is the minimum value? Here the minimum value is minimum value, maximum value, minimum index, maximum index. This is minimum, this is maximum. This is index, minimum index, this is maximum index. Okay, so initial value minimum is equal to error of 0. Error of 0 is 5. So here the minimum value is 5. Maximum minimum index is 0. Then maximum value is error of 0. Maximum value is 5. And then maximum index is 0. Now we are comparing these two values. So a of I is equal to, అక్కడ I value is 1, I less than or equal to 9. Yes, condition true. If minimum value is 5, 5 greater than or equal to, minimum value is 5, 5 greater than or equal to error of I. Error of I is 9. So 5 greater than or equal to 9. Condition false. The statements are not executed. Next, maximum value is 5, 5 less than error of I. Error of I value is 9. Yes, condition true. Then maximum value is, this maximum value is replaced with error of I. Error of I value is 1, error of 1, that value is 9. Here the maximum value is 9. Then maximum index is I. Here maximum index is 0 is replaced with 1. Next, I value is incremented. Here the maximum value is 9 and then maximum index is 1. Next, I value is incremented by 1. I value is 2. Now you have to check error of 2 with error of 2 with the minimum value. Here the minimum value is 5. So 5 greater than error of 5, 4. 5 greater than 4. Yes, condition true. Then the minimum value is error of 5. That means the minimum value is 5 is replaced with 4 and then minimum index is I. The minimum index is I. I value is 2. Next, once again check this condition. Maximum value is 9. 9 less than error of 5. Error of 5 value is 4. 4, 9 less than 4. So condition fail. The statements are not executed. Next, psi value is increment by I value is increment by 3. Once again you have to check 3 value to error of 3. So minimum value is 4. 4 greater than error of 5, 10. So condition fail. These statements are not executed. Next, maximum value is 9. So 9 less than error of 5. Error of 5 value is 10. So 9 less than 10. Yes, condition true. Then maximum value is 9 is replaced with error of I value 10 and the maximum index is replaced with I value is 3. Next, I value is increment by 4. Next, I value is increment by 4. So error of I value is 8. Error of 4 value is 8. So minimum value is 4. So 4 greater than error of I value is 8. 4 greater than 8. Condition false. These statements are not executed. Next, maximum value is 10. So 10 less than 8. 10 less than 8. Condition false. So these statements are not executed. Next, I value is increment by 5. Next I value is 5. Now we have to check error of 5 value. So 5 less than 9, yes, condition true. Here the minimum value is 4 greater than error of 5 value is 28. 4 greater than 28, condition false. These statements are not executed. Next, max value is 10. So 10 less than 28, yes, condition true. Then maximum value is replaced with error of 5. Error of 5 value is 28. Next, maximum index is 5. Here maximum index is replaced with 5. Next, I value is incremented by 6. The minimum value is 4. Next, I value is incremented by 6. Now error of I means error of 6. Minimum value is 4. 4 greater than error of 6. 3. 4 greater than 3. Yes, condition true. Then minimum value is, this one is replaced with 3. Next, minimum index is replaced with I value. Index value is 6. Next, maximum value is 28. 28 less than error of I. Error of I value is 3. 28 less than 3. Condition false. These statements are not executed. Next, I value is increment by 7. Next, I value is 7. Now error of 7 value is 6. If the minimum value is 3, so 3 greater than error of I 6. 6. 3 greater than 6. Condition fail. These statements are not executed. Next, maximum value is 28. So 28 less than error of I 6. This condition is also failed. These statements are not executed. Next, I value is incremented by 1. Next, I value is 8. Next, minimum value is 3. So 3 greater than error of 8, 21. 3 greater than 21. Condition fail. These statements are not executed. Next, maximum value is 28. 28 less than error of I 21. 28 less than 21. Condition fail. These statements are not executed. Next, I value is incremented by 1. Next, I value is 9. Next, minimum value is 3. 3 greater than error of I. Error of I 1. 3 greater than 1. Yes, condition true. Then minimum value is 1. This value is replaced with 1. Minimum index is 9. Next, maximum value is 28. 28 less than error of I 1. Condition fail. These statements are not executed. Next, I value is increment by 10. Next, 10 less than 9. Condition fail, out of the loop. Okay. After execution of this code, the minimum value is present in which variable? The minimum value is the minimum value is 1, which is minimum index is 9, maximum value is 28, maximum index is 5. We have to print these values. Okay, now how to first we know how to convert this code. Okay, now we have to convert this one into our C program. Now how many variables you have to declare in this code? You have to use how many variables? One is integer variable, integer array of size 10, next minimum and minimum index, maximum and maximum index. Okay, next you have to scan the array elements. After scanning you have to enter the same values 5, 9, 4, 8, 10, 8, 28, 3, 6, 21 and 8. Now you have to convert this code. Declare how many variables? Minimum, minimum index, maximum index, I for loop. Okay, now we have to convert this one into our C program. How to convert this one into our C code? So F2 I will take file name is minimum.c. Okay, so void main. Here you have to use how many variables? Int array of size 10. Next we are using int minimum value, minimum, int maximum, int minimum index, int maximum index. Next loop purpose you have to use I. Okay, next I am using CLRS here to clear the screen and ask the end user to scan the array elements. So printf enter 10 array elements. And scanf percentage d comma. Okay, how many elements you have to scan? Array of 0 to array of 9. Next here I am writing loop I is equal to 0, I less than 10, I plus plus 0 to 9. Here I am asking printf /n enter first element, enter percentage d element. Here I am writing I plus 1. I value initial I value 0. That's why I am writing I plus 1 and scanf percentage d comma address of error of I. Okay, after scanning, first you have to assign minimum value is equal to error of 0 and maximum value is equal to error of 0, maximum index is equal to 0, then minimum index is equal to 0. Okay, so instead of writing 4 statements, here simply write minimum is equal to maximum is equal to error of 0, minimum index is equal to maximum index is equal to 0. Here you have to write the logic for you have to compare first element to ninth element. You have to write for I is equal to 1 to I less than 10, I plus plus. Here you have to compare first element if minimum value and error of I value. If error of I value is less than minimum, that's minimum is greater than error of I. That means you have to assign minimum value is error of I, then minimum index is I. If we have to compare maximum value and error of I, compare these two values. Whenever ARR of I value is greater than maximum value, maximum is less than ARR of I, then you have to assign max is equal to maximum value is equal to ARR of I, and then maximum index is equal to I. So after completion of this code, the maximum value is present in minimum value present in min variable, maximum value is present in max variable. You have to print that values. So printf /n, so minimum value is equal to %d space minimum index is equal to %d, comma minimum value is present in min, minimum index is present in min I, and then printf /n max value is equal to %d max underscore index is equal to %d, comma max index. Just save this file. Just here I am writing. So Alt F9, compilation and Control F9. First you have to debug that code. Okay, Windows watch. In this, how many variables are defined? Debug, watches, add watch. I want to show ARR. Next min, next value is max, next value is minimum index, next one is maximum index, next I value. So F7, so memory is allocated for all the variables. So this loop is repeated, so 10 times. First element is stored in this address, second element, third, fourth, fifth, sixth. Okay, so F7, enter first element. Here I am entering first element is 594. F7 9 F7 4 F7 10 8 28 10 F7 8 F7 28 F7 3 6 21 3 6 21 then 1. We have entered, so 10 elements. In these 10 elements, the minimum value is 1, minimum index is 9, maximum value is at index number 6, maximum value is 28, at index 5. Okay, so F7. So in this code, the minimum maximum value is 28 and minimum value is 1. The maximum index is 0, 1, 2, 3, 4, 5 and minimum index is 9. You have to check that values. So Windows watch. So here starting. So minimum value is, maximum value is ARR of 0. ARR of 0 value is 5. Minimum index is 0. Maximum index is 0. Minimum index. By mistake you are giving max index. By mistake here we are giving minimum index is by mistake max. Okay, no problem. Minimum index is 0. First check this condition. So better to go and take minimum index is minimum index is 0 and maximum index is 0. So F7 once again first time 1, once again you enter the values 6 5 9 4 5 9 4. Next one is 10 8 28. 10 8 F7 28. Next values is 3 3 6 21. 3 6 21. Next value is 1. Okay, so 10 array elements. So F7 so minimum value is 5, maximum value is 5, minimum index is 0, maximum index is 0. First I value is 1, I value is 1, 1 less than 10, yes, condition true. Check the 5 and these two values. This condition is fail. Minimum value is 5 greater than 9, condition false. Next control, these statements are not executed. This control goes to this statement, this one. So max value is 5, 9. Max is 5 less than 9, yes, condition true. Then max value change it to 9. Look at here, max value is change it to 9 and max index is 1. This maximum index is 1. Change it to 1. Once again, next I value is 4. Now compare these two values. Minimum is 5, 5 greater than 4. Yes, condition true. These statements are executed. Minimum value is 4. These statements are executed. Minimum value is 4. 4. Minimum index is, this index is changed to 2. 2. Next max value is 9. 9 less than 4. Condition fail. These statements are not executed. Next I value is 3. So 3 less than 10. Yes, condition true. Now you have to check the minimum value 4 and 10. So 4 greater than 10. Condition false. These statements are not executed. Next 10 and 9. Max 9 less than 10. Yes, condition true. These two values, max value is 10. That's why max value changed to, we are assigning 10 to max. This max value is changed to 10 and then max index is 3. This index is changed to 3. Once again, next value is 4. I value is 4. Now you have to check it 8 with 4. So minimum is 4. 4 greater than 8. Condition fail. These statements are not executed. Next max value is 10 and 8. 10 less than 8. Condition fails. These statements are not executed. Next I value is 5. Now you have to check these values. 4. Minimum value is 4 and 28. 4 greater than 28. 4 greater than 28. Condition false. These statements are not executed. And max value is 10 and 28. 10 less than 28. As condition true. These two values, in these two values, max value is 28. This true. Then we have to assign error of I values to max. Though the max value is 28. Let's change it to 28. Then maximum index is 5. This index is changed to 5. Next 6. Minimum is 4. 4 greater than 3. As condition true. then minimum value is changed to 3. Here the minimum value is 3, then minimum index is 6. The minimum index is 6. Next, this condition is failed. These statements are not executed. Next, 6 and 3 condition failed. These condition also failed. These statements are not executed. Next, 21 and 3. This condition failed. This condition also failed. These statements are not executed. Next, I value is 1. So 3, 1. 3 greater than 1. Yes, condition true. Then minimum value is 1 is assigned to minimum. If the minimum value is 1, then minimum index is 9. This value changed to 9. This one is failed. Next, I value is 10. 10 less than 10, condition falls out of the loop. After completion of the, whenever control goes out of the loop, this statement will be executed. Now the minimum value is 1. 1 is replaced here. The min space value 1 space min underscore index value is minimum index is 9. Alt F5. So min value is 1, minimum index is 9. So F7. Next, max value is 28, maximum index is 5. Alt F5. Okay. So you have to debug this code like this. Okay. So still you have to any doubts, please refer once again. Thank you for watching. Hi everybody, welcome to SMR Telugu Education. So next program is write a program to find reverse of an array. To find reverse of an array. Okay, so what is the input? Input is you have to enter one array of size 10 elements. Here I am taking array of size 10 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I am entering the elements 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. These are the array elements. Okay, so array name is ARR. First element is ARR of 0. ARR of 0. Next one is ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5, ARR of 6, ARR of 7, ARR of 8, ARR of 9. So some addresses 500, 502, 500 and so on. Okay. Here the array name is array name always gives base address of an array. Array name is ARR. Now we have to find the reverse of an array. So please remember our total how many elements are there? 10 elements. Okay. So first index is how to reverse the array. Here So we are interchange these two values. Next we have to interchange these two values. Next we are interchange these two values. So we are interchange these two values. Next we are interchanged these two values. Now we get the resultant matrix is, the resultant array is first element, second, third, fourth, fifth, sixth, 7, 8, 9, 10. If the indexes is same, year of 0, here the value is 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay, so this is very simple. We have to interchange, first we have to interchange the elements of, first element is 0, error of 0, and then error of 9. We have to interchange these two values. Next error of 1, and then interchange error of 8. Next error of 2, interchange error of 7. Error of 3 can be interchanged with error of 6. Error of 4, error of 5. Okay, so now we have to interchange half of an array. So here the size of an array is 10. You have to interchange up to half. Here the index starts from, here I value is 0, 1, 2, 3, 4. The I value is 0, 1, 2, 0, 1, 2, 3, 4. Okay, we have to interchange I value 0 to 9. We have to interchange 0 and 9. 9, 8, 7, 6, 5. Okay, so please observe the logic. We have to interchange 0 and 9, 1 and 8, 2 and 7, 3 and 6, 4 and 5. Our loop is from 0 to 10 elements. You have to interchange the half of array. That means I value is starts from 1, I value is 1, I less than 5, half of an array. Array size is, array index starts from 0, I is equal to 0, I less than 5, I plus plus. Okay, so now high values are 0, 1, 2, 3, 4. We have to interchange 0 and 9. Here I am writing logic. 9 can be written as 9 minus 0. 8 can be written as, here I value is 0, then you have to interchange 0 and 9. I value is 1 and 8, you have to interchange 8. Here 9 minus 1. Here I value is 2, you have to interchange 9 minus 2. Here I value is 3, we have to interchange 9 minus 3. 9 minus 3 value is 6. Now I value is 5, you have to interchange 9 minus 4. 9 minus 4 value is 5. Now in first iteration we have to interchange error of 0 and error of 9 minus I. Here please remember, here 0, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. These values are present in which variable? I. That's why here we have to interchange I value, error of I value and error of 9 minus I value. Up to half of array we have to interchange or swap of error of 0 and error of 9 minus I. So how to swap two variables we already know. A is equal to 10, A is equal to 10, B is equal to 20. Then how to interchange A and B values? Simply A is equal to A plus B, B is equal to A minus B, A is equal to A minus B. If the A value is 10, B value is 20, A plus B value is 30. So A value is 30. Next, B is equal to A minus B. A value is 30, B value is 20. So B is equal to A minus B, 30 minus 20. Then B value is 10. Next, A is equal to A minus B. A value is 30, B value is 10. 30 minus 10. So B value is 20. Control Z. A is equal to A minus B. A value is 30 minus 10. 20 is assigned to A. So A value is 20. So just write this code. The two values are interchanged. Okay. Similarly, error of 0 is one element, error of 9 minus I is another element. How to interchange these logic? So this one is error of 0 and error of 9 minus I. this value is a, this value is b. Here a is equal to error of 0, then b is equal to error of 9 minus I. So add these two values. So add error of 0 and error of 0 plus error of 9 minus I. Add these two values and assign to another variable, either error of 0 or error of 1, your wish. Here I am assigning error of 0 is equal to, just a is equal to a plus b. So b is equal to, that means error of 9 minus I is equal to error of, instead of error of 0, we have to write error of I. Here starting I value is 0, that's why here you have to write error of I and error of 9 minus I. So error of I is equal to error of I plus error of 9 minus I, error of 9 minus I is equal to error of I minus error of 9 minus I. Error of I is equal to error of I minus error of 9 minus I. So first time, for I is equal to 0, I less than 5 as condition true, and interchange error of 0 and error of 9. These two values are interchanged. This value is 100, this value is 100, this value is 10. Next I value is increment by 1, 1 less than 5 as condition true. Swap error of 1 and error of 9 minus 1, 8. These two are swapped. This value is 90, this value is 20. Next I value is increment by 3, 3 less than, increment by 2, 2 less than 5 as condition true. Then error of 2 and error of 7, error of 9 minus 2, value is 7. These two values are interchanged. This value is 80, this value is 30. Next I value is 3, 3 less than 5 as condition true. Error of 3 and error of 6, these two values are interchanged. This value is 70, this value is 40. Next I value is 4, 4 less than 5 as condition true. Error of 4 and error of 9 minus 4, 5. These two values are interchanged. This value is 60, this value is 70. Now I value is 5, 5 less than 5 condition false out of the loop. Now our array is interchanged 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. Now how to convert this one into our C language code. Okay. So in this, how many variables you have to using? We have to declare a single array of size 10 elements. We have to scan that values and declare one variable I for loop purpose and write this logic inside this loop. Okay. Now we are converting. Alt F new F2, file name is reverse.c F5. Here I am using void main. So how to declare array? Into array of array size is 10. We have to scan that values and loop purpose we are using I clr scr to clear the screen. So printf, ask the end user to enter the array elements. Enter 10 array elements and scan the value. For I is equal to 0, I less than 10, I plus plus. So ask the end user enter the first element. So slash n enter percentage d element. Comma I plus 1. So enter first element and scan the values. Scan a percentage d comma address of error of I. Okay. So by using pointers concept directly, instead of writing address of I, we have to write another way. We will write later. Okay. Now we have to write the logic for swapping of reverse the array. Okay. We have to start from 0 to half of an array. We have to interchange the first element into last element. Okay. Here the last element is 9. That's why here I am writing 9 minus I. Sometimes last element is 9. Then you have to write n. Then you have to write n minus 1. That's okay. So for we have to interchange from 0 to I less than 5, I plus plus. So interchange logic, error of I is equal to error of I plus error of 9 minus I. Then you have to assign error of 9 minus I is equal to error of I minus error of 9 minus I. So error of I is equal to error of I minus error of 9 minus I. This is the swapping logic, swapping of two numbers. Okay. So after execution of this code, you have to print the array. So printf, I am giving one message. So array after swapping, after reversions. Give slash n array after reverse. Okay. So for I is equal to 0, I less than 5, I plus plus, and print the values. So printf percentage d comma error of I. So save this file F7. Yes. So our execution always starts from main function. So remove all watches and then add error. Okay. So if memory is allocated for 10 elements, here also I am writing I value I initial value is garbage value. Printf enter 10 elements. First element I am entering 10. This loop is repeated 10 times. 1, second time 20, third time 30, fourth time 40, fifth time 50, 60, 70, 80, 90, 100. So this loop is repeated 10 times. I value is 10, condition false, then control goes to out of the loop. Now enter elements are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I value is 10. Okay. Now I value is 0. 0 less than 5. As condition true. F7. Here ARR of 0 and ARR of 9. These two values are interchanged. 9, 10 plus 100. 110 is assigned to ARR of I. 110. Next 110 minus 100. Value is assigned to this one. 10 is assigned here. Next 110 minus 10. 100 is assigned here. These two values are interchanged. This is the next I value is 1. 1 less than 5 as condition true. Once again these two values are interchanged. 20 and 90. 110. This value is 90. This value is 20. Next these two values are interchanged. 30, 80. Next fourth time these two values are interchanged. 40, 70. Next 4 less than 5 true. Next these two values are interchanged. 110, 50, 60. Next I value is 5, 5 less than 5. Condition false, out of the loop. Next this statement is executed after array after reverse alt F5. This is message. Next I is equal to 0, 0 less than 10, condition true. Here I value is 0, 0 less than 10, condition true. ARR of 0, 100, alt F5, 100 is printed. Next I value is 2, I value is 1, ARR of 1, 90, alt F5, 90. Next I value is 2, ARR of 2, 80, I value is 3, 70, alt F5, 70. Next I value is 4, 60, alt F5, 60. Next I value is 50, 40, 30, 20, 10. Next I value is 10, 10 less than 10, condition false, out of the loop. Okay. So better to give some space here. So F2, yes. So alt F9, yes, control F9. Enter 10 array elements. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So alt F5, output is array after reverse 100, 90, 80, 70, 60, 50, 40, 30, 20, 10. Okay. So still you have any doubts, please repeat once. Thank you for watching. Hello everybody, welcome to SMR Telugu Education. So next topic is sorting the data. So bubble sort. So arrange the data in sorting order. Okay. Here I am taking the array of size 6 elements. First element, next element, next, 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 next. So total 6 elements are there. First element is 6, next element is 3, next element is 10, 5, 28 and 1. These are the array elements. You have to arrange these elements in sorting order. Every array has some name. First element is ARR of 0, ARR of 1, ARR of 2, ARR of 3, ARR of 4, ARR of 5. Here first index starts from 0 to n minus 1. Here I am taking the base addresses, some address 500, 502, 504, 506, 508, 508. Okay. So how to arrange these elements in a sorting order? So bubble sort follow some algorithm. You have to follow the same thing. First you have to compare first element and second element. You have to compare these two. You have to compare these two values. Next you have to compare these two values. Next you have to compare 6 and 10. Next you have to compare. So in bubble sort, first you have to fix the first element. First element. In bubble sort, sorting is from right to left. Sorting is from first in first pass. Here there is a word called iteration or pass. First iteration or first pass. The highest element is shifted to ARR of 5. So what is the highest element in the array is 28. This 28 is in first pass or first iteration. The highest number is shifted to ARR of 5. In first pass, you have to compare this value into this value. We have to compare these two values. If this value 6 is greater than 3, this value is greater than this one, then you have to shift these two values. Okay, this is the first comparison. Next you have to compare these two values. If this value is greater than this one, you have to shift these two values. Next you have to compare this value into this one. If this one is greater than this one, then you have to interchange these two values. Next one, you have to compare this value into this thing. If this value is greater than this one, you have to shift these two values. Next you have to compare this number into this value, then you have to shift this value is greater than this one, you have to shift these two values. In pass 1, how many comparisons are there? This is first comparison, this one is second one, next one is third, next one is 4 and 5. In first pass, number of comparisons is 5. So number of comparisons is 5. So in first pass, which one is the highest element is shifted to error of 5. First you have to compare this element error of 0 and error of 1. First here you have to compare error of 0 is greater than error of 1. Here I am comparing 0 and 1. Then you have to shift these two values. In this case the condition is true, then you have to shift error of 0 and error of 1. Here I am shifting these two values. Here the value is 3, here the value is 6. Next you have to compare error of 1 and error of 2. We have to compare these two values. If error of 1 is greater than error of 2, then you have to shift these two values. Error of 1 is 6 is greater than 10, so condition fail. Then next you have to compare error of 2 and error of 3. Next you have to compare error of 2 and error of 3. If error of 2 is greater than error of 3, then you have to shift these two values. Error of 2 is 10 is greater than 5. Yes, condition true. Then you have to shift this value is 10, then this value is 5. Next you have to compare error of 3 and error of 4. Error of 3 is greater than error of 4, then this condition is true. Error of 3 is 10 and error of 4 is 28. If this condition is true, then you have to shift these two values. So this condition is failed. Next you have to compare error of 4 and error of 5. Next you have to error of 4 and error of 5. You have to compare these two values is greater than. So this condition is true. Error of 4 is 28, error of 5 is 1. Then you have to shift these two values. This value is 1, this value is 28. So after completion of the first pass, the which element is the highest element is come to the last. Okay, now in this first iteration or first pass, how many comparisons total? This is 1, 2, 3, 4, 5. So total how many comparisons in first pass? Total 5 comparisons are there. Okay, now after completion of the first pass, the elements are in this position. This one is 5, this one is 10, 1, 28, 3, 6. Okay, next in second pass, in second iteration, in iteration 2, in second pass you have to compare error of 0, error of 0 and error of 1. If error of 0 is greater than error of 1, then you have to shift these two values. This condition is failed. Then you have to compare with error of 1 is greater than error of 2. If this condition is true, then you have to shift these two values. This value is 5, this value is 6. Next one, you have to compare error of 2 is greater than error of 3. So error of 2 is greater than error of 3. This condition is failed. Next you have to compare error of 3 and error of 4. So error of 3 is greater than error of 4. Here error of 3 is 10 is greater than 1. Yes, condition true. Then you have to shift this value is 1, this value is 10. This is second pass. In second pass, total how many comparisons are there? Total 4 comparisons. First time total number of comparisons is 5. Now the number of comparisons are 4. This is the first pass. Our index value I is starts from 0. This is I will take, this one is pass 0. I value is 0. This one is I value is 1. So after completion of the 2 passes, this is the first iteration. The highest value is goes to last place. In second pass, next highest is goes to error of 4. In third pass, we have to compare error of 0 and error of 1. If error of 0 is greater than error of 1, then you have to shift these two values. This one is failed. Next you have to check error of 1 is greater than error of 2. So error of 1 is 5 is greater than 6. Condition failed. Next you have to check error of 2 and error of 3. Error of 2 is 6 is greater than 1. Yes, condition true. You have to shift these two values. So shift these two values. Here the value is 6. This is the value is 1. So in pass 3, number of comparisons is, here the number of comparisons is 3. Next, this is the second pass. In pass 3, first you have to, after completion of the third pass, third iteration, the third highest values comes to third place. Next one is in fourth pass, we have to compare error of 0, error of 0 and error of 1. Error of 0 is greater than error of 1, then you have to shift these two values. Error of 3 is greater than 1, condition false, Next one, you have to check error of 1 and error of 2. If error of 1 is 6 is greater than 1, yes, condition true, then you have to shift these two values. This value is 1, this value is 5. So in fourth pass, how many comparisons are there? 2 comparisons. 2 comparisons. In fifth pass, you have to compare error of 0 and error of 1. If error of 0 is greater than error of 1, this condition is true, then you have to shift these two values. Error of 0 is 3 is greater than error of 1, yes, condition true, then you have to shift these two values. So this value is 3, this value is 1. Here the number of comparisons is 1. See, please observe, here the number of the array size is 6, then number of passes is 0, 1, 2, 3, 4. That means 5 passes or 5 iterations. That means the I value is 0, 1, 2, 3, 4, 4. That means the number of passes is 5 passes. If the size is n, then number of passes is n minus 1. So last element, only a single element, there is no comparisons. Okay. If I is equal to 0, then you have to compare. So how many comparisons? 5 comparisons. In first iteration, you have to total how many comparisons? 5 comparisons. Here you have to compare from 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5. That means here I am taking the starting value is 0. Here the starting value is 0. We are comparing with 1. Next value is 1. We are comparing with 2. Here I take the starting value is fixed 0, 1, 2, 3, 4. Here also the starting value is 0, 1, 2, 3. Starting value is fixed 0. Here also starting value is 0, 1, 2. The starting value is fixed. Here also the starting value is 0, 1. The starting value is fixed. Here the starting value is 0. So in each iteration the starting value is fixed. So how to convert this one into code? So first outer loop is starting value is fixed. So starting value is 0. So last value is fixed or not? We don't know last value, leave it. I is equal to I plus 1. This is the outer loop. Here the array size is take array size is n. Here array size is 6. If array size is 6, then here the number of passes is 0, 1, 2, 3, 4. That means here you have to write 0 to 5. 5 means less than n minus 1. Then you have to, this loop is repeated how many number of times? 0 to n is 5. Then I value is g 0, 1, 2, 3, 4. Okay, next. Here the comparisons, each comparison, first 0, second comparison also 0, next also 0, next also 0, 0. So in this starting value is fixed. Here I am taking another inner loop. So j is equal to 0, starting value is fixed, j less than or equal to, every time j is incremented by 1, j is equal to j plus 1. Here we are comparing with, 0 and 1, 1 and 2, 2 and 3. Here we are comparing j value is incremented by every time 1. That's why here I am incrementing j value is 1. Here you have to think about what is the last value. So this inner loop is repeated fixed number of times or variable number of times. So this inner loop is repeated. First, how many number of times loop is repeated? 5 times. Second time, how many comparisons? 4. Next time, how many comparisons? 3. Next time 2. Next time 1. Okay. Now here the value of n is, so value of n is 6. This is the I value. I value is 0, 1, 2, 3, 4, 5. How to get 5, 4, 3, 2, 1? So here the last value is variable value. First year we are writing, no need to write r equal to, I am writing less than, array is always less than, 0 to less than. Here total how many comparisons? 5 comparisons. That means here you have to write, what is the value? Starting you have to write 5. Then this loop is repeated 5 times. Next time here you have to write 4. Next time this loop is repeated, so 3 times. Here you have to write 3. Next time 2. Next time 1. That means the inner loop is repeated variable number of times. That means here we have to write some variable value. First here the j is repeated how many number of times? first j is repeated. First how many? First you have to write 5, then this loop is repeated 5 times. Next time is 4, then this loop is repeated 4 times. Next 3, next time 2, 2 times. Next time 1, next time 1, 1 time. Now here you have to write some variable. Now here we are comparing error of 0 with error of 1. Here we are comparing error of 0 and error of 1. That means error of j. How to get 1? We have to add plus 1. Error of j and error of j plus 1. Here j value is 1. We are comparing with next element j plus 1. Here the j value is 2. We are comparing with 3 j plus 1. Here we are comparing error of j and error of j plus 1. If error of j is greater than error of j plus 1, then you have to interchange the values. Here I am checking the condition. If error of j is greater than error of j plus 1, then interchange error of j and error of j plus 1. Swapping of two values. We already know how to swap these two values. Okay. Now what is the condition here you have to write? Here first you have to write 5. Next time first you have to write 5. Next time is 4. Next time is 3. Next time is 2. Next time is 1. How to write these values? Here, so what is the value of first? How to get 5, 4, 3, 2, 1? Here the n value is 6. I value is 1. Next 6, second iteration 6, 1. Next one is 6, 2. Next one is 6, 3. Next one is 6, 4. Here I am writing n minus I. Value is 6. N minus I 5. Here the n minus I value is n minus I value is 6, 5, 4, 3, 2. This is the n minus I value. But how to get 5, 4, 3, 2, 1? Decrease one value minus 1, minus 1, minus 1, minus 1, minus 1. Here you have to write n minus I minus 1. So starting value I is in first pass I is equal to 0, I less than 5, condition true. Then this loop is repeated how many number of times? 5 times. This is first. This is the first comparison. This is the second. This is the third. This is the fourth. This is the fifth. If the condition is true, then they are interchanged. After completion of the first pass, the highest values goes to the last position. In second pass, number of comparisons is 4. Then highest values goes to next place. Now how to convert this one into code? In this program, how many variables are using? N, the size of array, next I and j. Alt F, new, F5, F2, save. File name is some name .c, void main. Okay, so here declaring array of size. Our wish, here I am taking array size is 6, or if you want you can scan n value from the user. Array size is 6 and scan the array values I for I and j. Clear the screen. Ask the end user to enter the values. Enter array elements. For I is equal to 0, I less than 6. Here I am writing fixed 6 values I plus plus. Here printf slash n, enter percentage d element, comma I plus 1. So enter first element, second element, some message and scan the values. Here I am using address of ARR of I, or if you want you can directly write ARR plus I by using pointers. Okay, we have to scan the values. Next you have to write the logic for swapping, logic for bubble sort. First, number of passes is n minus 1, that means total number of passes 5. For how to convert this one into code. This is the outer loop. In this outer loop, this is the initialization, this is the condition, this is the iteration. So in this outer loop, you have to write once again the inner loop. This is initialization for I is equal to 0, condition I less than 6 minus 1, that means 5, I plus plus. So in this outer loop, once again you have to write the loop. J is equal to 0, J less than, here the condition is n minus I minus 1, J plus plus. Here we are comparing f j and f j plus 1. If error of j, that means error of 0 and 1, 1 and 2, 2 and 3, 3 and 4. Error of j is greater than error of j plus 1. Then interchange these two values. Error of j is equal to error of j plus error of j plus 1. Error of j plus 1 is equal to error of j minus error of j plus 1. Here error of j is equal to, this is the interchanging logic. We already know how to interchange two variables a and b. A is equal to 10, b is equal to 20. How to interchange? Same logic. Printf array elements are slash n. Okay, so for I is equal to 0, I less than 6, I plus plus, and printf percentage d, I am giving space, comma ARR of I. So F7, instead of n here size is 6 minus I minus 1. So F7 Windows watch. Here I am adding ARR and then j I and j values. I j and j plus 1 also, j plus 1. So our execution always starts from main function. Memory is allocated for 6 elements. So enter array elements. First enter 6, next 3, next we are enter 10, next one is 5, next one is 28, next one is 1. These are the 6 array elements. So please observe, this is the first pass. I is equal to 0, I is equal first in first pass, so j value is 0. Here total how many comparisons? 5 comparisons. A are of 0 and 1, 1 and 2, 2 and 3, 3 and 4, 4 and 5, total 5 comparisons. First j value is 0, j plus 1, both error of 0 and error of 1. This condition true or false? True. This code is executed. These two are interchanged. 3 is in error of 0 and 6 is in error of 1. Yes, these two are interchanged. Next, j value is increment by 1, error of 1 and error of 2, condition failed. Next, error of 2 and error of 2 and 3, yes, this condition is true. Then these two are interchanged. These two are 5 here, 5, 15, 5 and 10. Next, 3 and 4, this condition is failed. This code is not executed. Next, 4 and 5, this condition is true. Then 28 is here and 1, these two are interchanged. 28 and 1. See, first pass, what is the highest element is? Sorting is from right to left. In first pass, highest element is in last position. Next I value is 1. Next in second pass, next second highest is in the second place. Yes, true. Error of 0 and 1, this is failed. Next, compare these two values. True. These two are interchanged. Yes. Next, these two, condition failed. Next, 10, 1, this condition is true. These two are interchanged. 10 and 1. In second pass is completed. I is equal to 1 is completed. In this, second highest value is in second position. In third pass, I is equal to 2. Once again, third highest is come to this place. Comparison from 0 to error of 0 and error of 1. That's why j is equal to 0. This condition is j and j plus 1. Fail. Next, these two. Error of 0, 1 is greater than error of 2. Condition failed. Next, 6, 1. Yes, condition true. Then these statements are executed. These two values are interchanged. Yes. Next, so third pass is completed. Third iteration is completed. Third element is goes to third position. So in bubble sort, sorting is from right to left. Next pass, these two condition failed. Next, these two condition true. These two are interchanged. 5 is here, 1 is here. Next, I is equal to 4. These two are interchanged. Check the condition. Yes, true. These two are interchanged. Yes. Next, I value is 5. 5 less than 5. Condition pass out of the loop. Next, this statement is executed. Array elements are Alt F5. Array elements are F7. First element is So F7, so first element is 1, next second element is 3, F7 next element is 5, F7 next element is 6, F7 Alt F5 10, F7 Alt F5 28, F7 memory is deallocated. So this is the bubble sort. Here the number of passes is 1 to n minus 1. So how to write this code? By using pointers concept. Without using, similarly how to write, without writing address, simply how to write ARR plus I. Here also at the time of printing also, this can be also written as asterisk ARR plus 1. Both are same. I. Alt F9, yes, Control F9. First element is 3, 6, 2, 8, 10, 1. So Alt F5, same 1, 2, 3, 6, 8, 10. Okay, this is bubble sort. So please debug and write step by step. It is at the first time it is very difficult to understand. Okay. So still you have any doubts, please repeat once again. Thank you for watching.